is Mark Ryan, Senior Director Technical Product Specialist at Zscaler, and I'm going to show you how to deploy Zscaler Private Access in under 60 minutes. 4 simple steps to get Zscaler Private Access deployed. First step, configure the identity provider. So there's the service provider configuration, Zscaler, which we'll set up, and then we'll configure the identity provider, which we're going to use Azure AD as our identity provider. Get those 2 things working, we're able to authenticate users. Second part of the configuration, deploy the app connectors. We're going to deploy an app connector into AWS and into my physical data center. And we'll do that. We'll create a provisioning key in the Zscaler administration interface, drop those provisioning keys onto the connectors, and the connectors will join the cloud. Third step, we're going to configure the wildcard domain. So we're going to start off with a star.domain.com, and that'll allow us to dynamically identify applications in my data centers, in my infrastructure as a service, and provide access to those. We'll create an access policy which says everybody can access everything, and away we'll go. And then the fourth step, we'll deploy the Zscaler Client Connector to the workforce. In an enterprise, you deploy this using an MDM like SCCM, Intune, Jamf for your Macs and whatever. I'm going to deploy this with a command line, just install it. But generally in your environment, you might take a couple of hours to obviously do some testing, integration and whatever, but you push this out relatively quickly. And then we'll be able to pass traffic through the service. So without further ado, we'll minimize this and we're going to go to the administration interface. I'm using the Zscaler Beta Cloud for this demonstration today, but you would normally go to admin.private.zscaler.com, which is the production cloud. So you're going to sign in here, and you'll be able to see this is a blank template. There's no applications going through here, and we're going to start with the IDP configuration. So we're going to start, add an IDP. We're going to call this Azure AD. It's our user authentication, and we're going to use my domain, which is welshgeek.net. We can click next. We have the SP metadata, so let's go ahead and download it. Zscaler is the service provider in this case, and for every instance we create, there is a unique URL and entity ID. So it's worth being aware of those. If you delete the IDP configuration and recreate it, the entity ID will change. So as you go through these steps, just be aware of that. We're going to click next, and it's going to ask us to create the IDP and upload that IDP information. So we're going to pause there, and we're going to come across to Azure AD. So I'm in Microsoft Azure. I've got my enterprise applications. I've got a number of them in here for a number of different reasons. But I'm going to click here, add a new application, and it's going to take us to the Azure AD gallery. I'm going to click search for Zscaler in there, and then we see the Zscaler Private Access over here. Obviously, there's an administrator access as well, but we're just interested in the user access, which is this one here. And I'm going to call this ZPA Welsh Geek Beta, because that helps me identify it later on. And I'll click Create. And what will happen is Microsoft will run their scripts in the background. They'll pull over the configuration. They'll create the application in my tenant and set up some of those default options that are needed. We'll then need to go in and make some configuration changes and things, and we'll be able to get things up and running. So here we are in the ZPA tenant, and the thing we need to go to is single sign-on, and we're going to configure this for SAML single sign-on. So there's a number of things that we need to click on with this. It needs to know the entity ID and all those other things that we were seeing in the private access console. What we do is we go ahead and we'll upload the metadata file. We'll select that metadata and we'll click add. Now, of course, it'll then pre-populate all of these details in here. The one thing that you do need to create is this sign-on URL, which invariably is used for IDP initiated sign-on, which we don't support, but Microsoft require you to put something in there. But we do know that we have a test URL, so we can enter https saml.sp.zpa.beta.net auth/v2 login domain equals wildcard.net. So relatively simple. And we don't need any of these other options because we are only doing SP initiated sign-on, so the rest of it is not needed. So we click Save. That'll update the settings over here on the left. Once that's saved them, we are all good. So we can close this over here. So we don't actually want to test anything. The next thing it needs to do, we have to configure a signing certificate. So I've got a signing certificate over here. Go ahead and make that active, or what we'll do, lovely things of Azure, we'll make a new certificate, and we will there we go. We'll click Save on that new certificate we've created. And we'll close these over here. And now we've updated the signing certificate that's going to be used to sign the SAML assertion. So now we have 3 steps that we need, and we can now download the metadata. Just maximize this window. So we've now got the metadata from Azure AD. So we can come back over to Zscaler Private Access. We can upload the metadata that we've just downloaded from Microsoft, and we can see all the configurations. So status is enabled. We're going to sign our request. This is interesting. It seems to have defaulted to HTTP redirect binding. We don't want that. We want to use post binding. So we'll disable that, and we'll click Save. If you are stuck with redirect binding sends the request as part of a GET request, and that means you're limited by the size of the URL in the address bar, or for the identity provider. So we're all set up here. We should now be able to understand about the attributes. So we can click here, import, and this will generate an SP initiated sign-on request over to Azure AD. The user will sign in, and we'll redirect back, and we'll see all the attributes that are being returned. It's a good way to verify that you've got your setup working correctly. So let's click import. It runs over. And what it's now saying is the user is not assigned the application. So we need to come back over to here, and we know about the users and the groups. In fact, if we come up here to the properties, it says here user assignment is required. So let's click no on that and click save. We're quite happy with all users having access to the application. Let's close that again, and let's test that import. It may take a second or two to provide access to the application. Click in here in users and groups, and we could assign it to the specific user, M. Ryan, and click select. We'll assign it, and we are good to go. So let's go ahead and click import. Runs over. It's done the authentication, and now it's going to tell us about the assertion that came back, and it tells us about all of these different groups that came back. So we know that it's sending through my tenant ID, object ID, my display name, and if we notice here, it is sending through all of the groups that I'm a member of, which is probably not a good idea. And it's also sending through as a GUID, meaning the object identifier from Active Directory. So that's not really very helpful. So let's come back into Zscaler Beta, and we'll take a look at, go back into my enterprise applications. And let's take a look at that single sign-on. So single sign-on is sending through user.groups. So let's edit this. We've got the groups, and what we actually want to send through is the SAM account name for the groups. We'll click Save, and we can close this window down and rerun that import again. And now that import will say, which groups am I a member of? Group 2, Certificate Auth Group, Internet ZIA. I've got a bunch of groups here that the user is in that come through as part of the assertion that I can then apply policy on later on. I've also got all of these. This is the attribute that comes back, and this is how we consume it. So I could rename these if I like. Tenant ID, because that's helpful for me. OID, display name, whatever makes more sense for you. So I like to give things easy attributes to apply policy on. And that makes things nice and simple for later on when we want to apply a bit more granular policy. So we've got the IDP set up. We're all ready to go to start authenticating users. So the next steps, we need to deploy the Zscaler app connectors. So we're going to deploy an app connector in Microsoft Azure. So I've got my Azure tenant here. I'm going to go and launch an instance. And the easiest thing to do, again, is search for the instance you want. And I've got one in the AWS Marketplace. So we've got two options here. We've got the Private Access Connector, that is the app connector, and the Service Edge, which is a private service edge. And it gives you functionality to keep data within your own data center. So that's this one isn't relevant for this demonstration. We're going to deploy the Private Access Connector. We'll click Select. It gives us some detail about the fact that Zscaler doesn't charge you for the software. It is included in your user license. And there is a cost to the EC2 instance types. Now we list all of the instance types here that you can install on. Obviously, recommendation is not to use T-type instances for production. T-types are essentially on-demand kind of instances. They are limited by IOPS, and they could start to cause you some kind of constriction in a production environment. They are perfectly appropriate for demonstration. Recommendation, use an M5 or a C5 kind of instance type for production. So I'm going to click continue on this. We then get to select the instance type we want from all of the instance types that are available to us. And you can see we've restricted what you're able to deploy to. So I'm going to deploy this to a T3 medium type. Click review. Oh, actually, we need to make a change because I need to make sure that we deploy in the right subnet. So I want this to be deployed into my public subnet. So that's in because it's going to be able to be routable to the internet. It needs to be. If you're deploying this, you possibly might consider deploying it in a private subnet and having it egress through a NAT instance or a NAT gateway. But for this deployment, I'm going to deploy it in a public subnet. So we're not worried about anything else. In these, we're going to click launch, and it's going to ask me for a key pair. So I'm going to use my existing key pair, and we're going to launch that instance. So that instance will take a couple of seconds to kind of instantiate and boot up. Whilst that is going on, we're going to come over to my administration console and click on connectors. So it's important to consider a connector is as an instance. it provides access to resources. You're going to have resources in different data centers, so it's important to consider where you place connectors and plan for that deployment. The other important thing to consider is the connector group. So a group of connectors is a data center. And what I mean by that is I might have 4 or 6 or 8 connectors in my AWS instance just to be able to manage all of that load and the number of transactions we're seeing. So I'd create one group for one AWS region, and I might create another connector group and deploy other connectors for another region, and I will create a third connector group for my physical data center in UK, for example. So a connector, you can have multiple connectors in a geography, and that should be a connector group. So we'll go ahead and we'll add a connector, and we're going to create a new provisioning key. We'll click next, and it's going to be signed by from a hierarchy perspective of certificates. We've got a root, and then I've got an intermediate certificate for my connectors, my machine certificates, my client certificates, and my private service edge. So we select the connector signing certificate. The connector signing certificate will sign all of my connectors provisioning keys. So I'm going to create a new connector group, and I'm going to call this AWS connector group. It's connectors in AWS US West, and I know that's in Oregon. So we need to provide this data because it'll help us with geolocalization. So click next. The provisioning key is PK for AWS. And I'll say this can be used 10 times. And it means, when I say 10 times here, that means that this provisioning key could be used to deploy 10 different connectors. I can always come back in later on and increase this number. If I was to delete the connector and add another one, it would, and use the same key, it would use against that 10 different number of instances. So 10 number of uses for that. We'll click next, we'll click save, and now I've got the provisioning key. So I'll copy that to my my notepad, and then I can follow any one of these different guides. It's going to tell me what I can do with it. So we'll click done on that. And if I come in here, I can then see that I've got my connector groups. Oh, that's interesting. That's a hangover from somewhere before. We'll delete that. And we'll delete that. So I come in here, I can see my AWS connector group. There are no connectors in there. 0 of the 10 have been used. So let's take a look at our AWS console. Let's refresh this, and I can see that I've got this new instance. I can name that. I should have named it when I went, but it's my Welsh Geek connector beta. Okay, so we know it's a T3 medium, and what we've got in here is the public EC2 IP address. So we'll copy that. And what we're going to do, we'll come to a terminal window. Go ahead and maximize this, make it easier for you all to read. We'll SSH minus I. This is my private key as part of AWS. And we're going to go admin at, and then my AC2 instance. So I'm on the command line. What I'm going to do, because we need to copy that provisioning key over, we're going to just jump to root cd/var opt Zscaler var, and you'll see it's just there, ready to go. So I just come back over to my thing because I realized I'd copied and pasted at the wrong time. We'll take a look at this provisioning key, and we will copy that provisioning key back to the clipboard, and we will vi provision underscore key, the easiest way to do this, and we'll paste that in there. So I pressed I for insert, pasted the provisioning key, we've edited it, we'll come out of edit mode, write and quit, and the provisioning key is there. So at this point, I can run systemctl start ZPA connector, and that will go off. It'll use that provisioning key. It'll enroll into the cloud, and we'll see. Need to restart it because it was probably already running. There we go. So it's, when it booted up, it was already running. So I needed to stop it and restart it to get it to read in the provisioning key and then try and join the cloud. And you'll see what it's done. It's encrypted that provisioning key. It's then gone off and it's created a number of certificates. It's joined the cloud. And we can see all of those things are running there. And it's able to process traffic. We run systemctl status ZPA connector -L, and we can see that it's gone off and it's downloaded and it's connected to the cloud. And there we go. So it should be able to run. And if I ping, so it's an example, my apache.welshgeek.net, Apache web server running in AWS, you can see here it's picked up the private IP address for AWS, and if I was to curl that, HTTP apache.welshgeek.net, we can see that it's able to go and get that content, and you can see this one is in AWS. So once we're able to get users passing through the service, I will show that we're able to access this application through ZPA Client Connector. Okay, so we're all up and running there. The connector is deployed. What I will also do whilst we're here, we'll see here that it's added that connector in there. It's running version 2028.5, so that's good. And it's in the AWS connector group with the connector enrollment certificate. I'm going to go ahead and add another connector because we want to. We'll create a new provisioning key, the connector connector intermediate. We'll create a new connector group because it's in a different data center. And these are my data center location. This is physical DC in UK. And I'm in London. I don't know why London, UK isn't at the top of that list, but I'm sure it's just alphabetical. And we'll click next. We'll create a new provisioning key. Provisioning key is PK for DC, and we'll say that can be used 10 times as well. We'll click next, we'll review that data, and we've got this provisioning key, and we'll click done. I'll copy that to my clipboard, and so what I'll do is I'll SSH admin at connector beta, and this is my physical data center that's local to me. So now I need to enter a password because it's a physical instance next to me rather than AWS using SSH keys. So this is my physical one. You can see in my physical data center 192.168.1.33. And so we'll do the same thing, sudo su minus, and we'll get prompted, and we'll go to cd opt zscaler var, and we'll vi provision underscore key in, because I highlighted it, it copied it to my clipboard. So here's my provisioning key again, copy the key. We're in insert mode, I can paste that, escape, write and quit. Let's just check systemctl status ZPA connector. So it's not running. So I can go systemctl start ZPA connector, and you can see it's already started to take that data. So it's taken you can see the provisioning key. It's gone from there. It's then encrypted it, joined the cloud, and if we run that status again, you can see it's taken the software version and it's connected to the cloud. And we can see that we're connected to the beta cloud in US West. So I now have, if we come back to the administration console, I have two connectors deployed. I have one in my physical data center and one in AWS. And we should now be ready to start processing traffic. Just whilst I'm here, I can then ping. I have another copy of my Apache server, apache.welshgeek.net. That's in my physical data center, 192.168.1.11. And if I curl that, apache.welshgeek.net, tells me I'm unauthorized. So it's got this one actually has authentication enabled on it, so it's a slightly different experience to the one in AWS, and we'll come to that later on. But we can see that the connector has the connectivity to the applications. Okay, so pair of connectors, one in AWS, one in Azure. We're now ready to start building policy. So we'll create an application segment. We'll start with an application segment and we'll say it's called wildcard. It's my wildcard domain application segment. We'll start with start.welshgeek.net. And for the port ranges, we'll go 1 to 655.35, 1 to 655.35. We have a couple of options down here about health checks and bypasses. We're going to be really simple here. We're going to say only bypass on the corporate network. If you're on the network, then it will bypass these applications. We're going to turn off health reporting because it's a wildcard health, so you can only monitor for health. We'll put it on access. You can only monitor for health when you're actually accessing an application. You can't do continuous health monitoring for a wildcard. We've got a bit of a pop-up here. Zscaler recommends excluding DNS traffic from TCP and UDP port ranges. And that's really specifically around IP addresses. So you don't want to have an IP application with port 53 because you end up in a loop because of your DNS traffic not being intercepted by ZPA. So we're going to click continue on this, and we don't worry about this for now. So every application has to be in a segment group, a group of applications. So we will add a segment group and we will call this internal applications. And we'll click next. And a server group. Now a server group is slightly confusing as a name terminology. So a server group is the dynamic discovery of servers, the servers that serve applications. You should never really define servers statically. So what we'll do is we'll create a server group and we'll call this dynamic server discovery. It's all dynamic servers discovered. And you'll see status is enabled, dynamic server discovery is on. And so and just to really emphasize this, there is nearly 0 cases where you would turn this off. And maybe engaging with Zscaler support or only turning it off or creating static servers on the guidance of Zscaler support or deployment services would be the best way to go. For 99.9% of use cases, dynamic server discovery should be on, and this is the only thing you should consider. So now we need to select connector groups that's associated with it. So we will ask AWS and the data center whether or not they can see the application. And then we'll make policy decisions to decide which one of these we're able to get to. So we'll click next, we'll click save, and then we need to build a policy. So we'll edit the policy. And we have to have policy. to be able to access things. So we'll click add a rule and we'll say default allow rule. And we'll say we've got our segment groups, internal applications, everything else, and we have an allow access rule. So we're not going to build any complex policy day one. Let's just allow people to access applications in the same way that they would if they were on a VPN. You're on the net. We're not obviously placing people on the network because we're a zero trust network access solution, but the policy should be analogous to what you get when you're on ZPA. So start simple and we'll build policy as we go. So access policy, application segments are created. We're all good to go. So now the only thing that's necessary is for me to install the Zscaler client. So what I've got here is the Zscaler app installer package on my workstation. And so what we'll do is we'll open Zscaler app, and we'll send two arguments. The first one is user domain is welshgeek.net, that's my account, and cloud name is Zscaler2. Now, of course, you'd package this up if you were on Windows and you'd send it out with these installer options using SCCM or Intune, or you'd use Jamf to deploy this to Macs, or you'd use, you could use Intune or AirWatch or whatever to deploy it to your mobile devices. So many different options to deploy the client, but really the only things you need to concern yourselves with is the automatic signing in and making sure that that client is tied to your tenant, so the user gets the best user experience of enrolling through the platform. There are other options, obviously, if you're using Zscaler Internet Access to do things like strict enforcement. The user has to have Zscaler app running, otherwise they can't get anywhere. And we can get into more detail about that in other sessions. So press enter on that. It's going to ask me for a password because it wants to make a change and it needs root access. So where we go, that will go off and install. We'll get a little pop-up. I could even make that silent with an installer option. And you'll see there that the client is there. Now in this instance, it's redirected. I've made a mistake. We're going to exit that because what I actually should have done was Zscaler Beta, because that's the tenant that we're using. So let's go ahead and reinstall it with the right option. Okay, so this time it's installed. It's going to launch the instance. Let's open this and see what happens, because it's now installing it. It's redirecting the user to the IDP to log in. And because the IDP is supporting Kerberos SSO, the user is transparently authenticated to the IDP, authenticated, and now we're signing in transparently. So the level of user interaction is literally zero once the package is deployed to the machine. So it's now registering the device with Zscaler Private Access. It's fingerprinting the device and it's enrolling and using those secure certificates to join the cloud. So we'll leave it a second whilst it does all the installation it needs. It's connected to Zscaler Internet Access. For some reason, Zscaler Private Access seems to have a little challenge there. There we go. Okay, we've properly authenticated and we're enrolled to the private access service. Okay, so we're all connected, and I've got internet access and private access running. So if I come to my browser here now and I go to ip.zscaler.com, Zscaler Client Connector is going to intercept that traffic and it's going to send it to the private access, the internet access platform. And you can see I'm going through the Zscaler Frankfurt node. During enrollment, if I check here, KList, I was Kerberos authenticated, and I got transparent authentication to Microsoft Azure. That's what enabled me to do the authentication and the transparent enrollment. So everything's working with the app enrolled. So let's go and have a look what happens when I access that Apache web server, apache.welshgeek.net. And as luck would have it, it doesn't work. So let's see if we can figure out what's going on. So it's managed to pick up the Apache server in AWS. And we know that it's picked it up in AWS because it's 164.1.1. Interestingly, though, it's picked up the CNAME for compute.internal, and internal is then a namespace that doesn't exist within private access. So what we'll do is we'll come over to our application segments, we'll edit this, and we'll say next, we'll add star.compute.internal, and we should save that. It seems to have picked it up in AWS. I think this is probably a caching problem. So let's go ahead and open up Safari instead and go to apache.welshgeek.net. So it's picked it up, and it's now seen the version that's running in my physical data center. So we've done some discovery. We've figured out that the closest version is the version running in my data center, and we've connected through Zscaler Private Access to that instance. Now let's say, for example, that I want to not send everybody, although I've got 2 copies of this web server, both in AWS and in my physical data center, I want to do something a bit more controlled. I want to move away from the wildcard application segment. So there's 2 things that I'm going to do. I'm going to come over to my server groups. And at the moment, this dynamic server discovery says, whenever I want to access an application, I'm going to ask both of these connectors, the connectors in AWS and the connectors in my physical data center, which one of those can see it. So for that Apache server, they can both see it. So it's going to use the dynamic nature to pass traffic to one or other based on my location and the best path. So let's go ahead and we'll add a server group, and we'll say this is just AWS. We're going to call it dynamic. We'll call it AWS server group. AWS servers. We leave it as dynamic server discovery, but we only want to use the AWS connector group for that. And we'll click save. And whilst we're here, I'll add another server group, and this is called DC server group, and this is servers in physical DC. And we'll just use the DC location. So I've now got these 2 definitions, different server groups. One server group that's going to try both locations, and that's my wildcard star.welshgeek.net. And I've got one for my physical data center and one for my AWS. So let's come over to my application segments, and rather than using all of my discovery, I am now going to say add an application segment, and this application segment is called apache.welshgeek.net. It's just my Apache server. And now, rather than using the wildcard, I will use the fqdn apache.welshgeek.net. And I know a bit more about this server, that it's only actually running on port 80. So I can restrict the access rules to just port 80. Anything that's not port 80 will therefore get dropped. And now, because I've defined it as a single port, I can leave continuous health reporting going on, and I can click next. Segment group, I want to specifically leave it in the internal applications, and I want to use the specific server group, which is the AWS server group. I want to steer all traffic for apache.welshgeek.net through the AWS connector, and therefore AWS connector associated with the server group, which is on dynamic server discovery. So it's dynamically going to figure out the IP address of the server that's running that Apache application. Click next, click save. I don't need to worry about the policy because the policy still says everybody can access everything. So I click cancel on the policy, and now I've got an application segment called apache.welshgeek.net. So now if I refresh this page, in fact, before I refresh the page, we'll just scroll up here slightly. We know that apache.welshgeek.net is 164.1.1. Well, instead of doing ping, we'll do DNS SD v4 apache.welshgeek.net, the lower level DNS resolution. We still know that it's 164.1.1. So it was in my physical data center as 1.1. Now it's moved back to AWS. It is still the same IP address as far as the client is concerned. We've refreshed this page. We can now see it's just in AWS. And you see the dynamic discovery has taken care of how we pass that traffic. Final thing to consider, for things like Active Directory, we need DNS search domains. So here is an option for DNS search domains. This is the same as your DNS search suffixes, which will be given out via your DHCP when you're on network, or might be put in if you are on a VPN. Your VPN concentrator would set some DNS search suffixes. So if you're accessing applications like DFS or NFS, you're making file shares accesses, you're doing things with SCCM, invariably they will often be accessed as a short name, /server/file share. But actually what goes on is your search domain appends a search suffix to create a fully qualified distinguished name. And Zscaler Private Access requires the fully qualified distinguished name. And this function provides that. So my domain is welshgeek.net. If I had other search suffixes, I would add more. We want Zscaler Private Access or the Zscaler Client Connector to actually intercept all of these things first. So we tick this box for domain validation. So click Save. And what that would mean is, if we come over here and I go File, we're going to go Connect to Server. I can create an SMB connection to the C share on my domain controller. We'll click Connect. And the dynamic server discovery will figure out which connector is able to manage that connection. We see now it's mapped the C drive. Obviously, this is a little bit on the slower side because I'm on the beta instance. It's going to the US and then back across to my physical data center to be able to map that drive. Not the most efficient path. But we'll let that load a second. There we go. Those are all of my file shares there. So I can do that, but that short name suffixes also means that if I was to do // let's try a different server, ADFS internal, one of my different servers, and click connect, it will automatically complete that to with the search suffix adfsinternal.wellskeet.net. It'll probably prompt me for some credentials or whatever. And if we did another K-list, we can see that I've actually gone off and got those Kerberos tickets, both for my Apache server, which was doing Kerberos authentication, for the CIF server, the fully qualified distinguished name, and for this short name. And with a bit of luck, we can figure out what's going on with that. So we've got the map drives for my Apache server, for my $C on my FQDN of my domain controller, the map drive for my short name of my ADFS server. So I've got a couple of different ways to map names, map file shares. So it's important this is configured as well. And then finally, we can take a look at the logs. We've made a number of different transactions as we've been going through. We can see here is my my connection for my Kerberos ticketing, port 88. We can see here's my 445 connection. That's the SMB or CIFS connection to my ADFS server. Here's the same connection for my domain controller, and here are my Apache server ones. And when we look at the Apache server, we can also see that initially it went through my physical data center, and after that it went through AWS. And of course, if I drill into any of these, I can see the path that was taken. We went through the physical data center, what the actual IP address was for the connection, both in terms of the source IP and the source port for the connector, and the destination IP and destination port for the connection. I can see the bytes transferred. I can see the user real IP, so what IP address I am on the internet. I can see all the data about the metadata. How did I authenticate? What SAML attributes were applied during my connection? If I was doing any kind of posture check, I could see that here as well. And we can download the full connection information that we wanted here. So we have all of this data at our disposal. We've managed to get things set up and running, and probably, without looking at my watch, in about 30 minutes from no private access configured at all to the IDP configuration set up, the connectors deployed, the policy created, and the application segments are appropriate for that, and then having the Zscaler Client Connector deployed. We've passed traffic, we've accessed a number of applications in the two different infrastructures, the physical data center and my AWS infrastructure, and we've seen all of that log traffic passing through. Hope this was useful. If you do have any questions, email me, mark@zscaler.com.